and run through this. There's several different concepts on this. All this stuff I'm doing tonight is goes to the final exam. Bits and pieces of it show up on the final exam. So what we're going to do with this one is what we were talking about last class basically was how you do the absolute value of a complex number. Okay, so I'm going to go ahead and let's write down what we're doing. We're doing the absolute value of a complex number. Now this time I'm just going to use the formula, because what you really have is, a complex number has the form a plus bi. So a is going to be 4 in this problem, b is going to be the 3/8. And what an absolute value is it's r, it's the radius that's drawn to that point on the complex plane, and then that's defined to be the square root of a squared plus b squared. Okay, where does that come from? That comes from the Pythagorean Theorem. Okay, the Pythagorean Theorem is just saying r squared is equal to a squared plus b squared. So all we're doing is finding that radius. Now, if you did plot this point out, and this one, if you just plotted this out, what you would do on the complex plane is you would go over 4, and then you would go up 3/8. Okay, you can hardly draw that on there, but it's kind of somewhere in there. So you're looking at a circle that goes around that point, and what you're looking at is that radius right there. That's what an absolute value is. It's as a distance a point is from 0, 0. Okay, so let's just crunch out the details. All right, I wanted to do one with a fraction. That's the reason I chose to do this example. Okay, so when we do this, we're going to have, this is going to be equal to the square root of a squared. Well, a is 4, so we need to square that, plus b squared. So b is going to be 3/8. We're going to square that like that. So we've got to work out the arithmetic. Now we're going to get an exact answer. We're not going to use decimals and stuff, so we're going to do that. All right, so when we do this, looks like we'll have square root of 16, and then 3 squared is 9, and 8 squared is 64. Okay, so we just need to do that. Now what we need to do here is we need to get a common denominator. So I'm going to put the 16 over 1, and then let's get a common denominator. We may have to use our calculator to help us a little bit with that, but what would be the common denominator, obviously? 64, right. So that means we have to multiply this by 64 over 64, okay? And you get a pretty big number. I'll have to check that on my calculator. So what we'll do on this is we'll do 16 times 64, and then that's going to give me 1,024. Okay, so I have 1,024 over 64 plus 9 over 64 like that. All right, everybody following along so far so good? Anything got a question on? Okay, so what do we have? We have square root of 1,033 all over 64. Okay, what else could you do to finish this up? I only think of one thing I could do. You can do square root of 64, right? So what you're really doing is when you have a fraction, you don't necessarily have to show this step, but you can do that. You can do square root of numerator and denominator. So the answer to this problem is r equals 1,033 over 8. Okay, that's the exact answer to that problem. So that's what the absolute value of 4 plus 3/8 I is. Okay? All right. Can't do that in your head like you can other absolute values, but all it is it's working out the Pythagorean Theorem. If you remember that, you got it made. Okay. Does that make sense what I did to everybody? Okay. Any questions about anything? Okay. All right. Now what we get into next here is kind of a real important thing that we'll be talking about, into next week, is the trigonometric form of a complex number. This stuff that we're doing here is real abstract. If you're going to take higher math, it'll show up a little bit in calculus, differential equations, and stuff like that. You probably won't see this again, though, until you're maybe either in Calc 2 or Calc 3. Okay, it just depends. But you'll see this a little bit in Diff EQ. If you're going to major in math like I did, then you'll take a whole class called Complex Analysis, and you'll just love it. Okay, it's an awesome class. All right, so here's what I want you to do on this then, is we're going to just put a point here. Okay, just put a dot there and call that A plus BI. Okay, like that. Now what we're going to do is we're going to try to develop how you can write a number with trigonometry. Okay, so what I'm going to have you do first of all is let's go ahead And let's draw a radius to that. Okay, this is going to be a familiar diagram to you. It's going to look like what we've been doing 100 times this semester. Okay, let's label that R. That's your radius. Now what you have is you have a circle going around that complex number, kind of like that. Okay, and then what we'll do is we'll go straight down to the x-axis at a right angle like that. Okay, we're going to call this theta, and then we're going to call this, what would be the base of this triangle, by the way? It'd be A. How come? Because we went over A, right, on the complex plane. Okay, what would be the height of this? B, because we did that. All right, so what we're going to do on this is we got to find a trigonometric ratio, between several things. We're looking for a couple of things. We already know what R is, okay? So in the triangle, we're going to have this. We'll have R squared equals A squared plus B squared, like that, all right? So we're going to kind of look at that a little bit, first of all, to find what R is. So we're going to do square root like that, so we'll end up having that. That's just the radius, okay? Now the next thing I'm going to do is, so we're going to have R equals this, and that part right there is called the modulus, okay, of the complex number. That's really given the absolute value of the complex number, like we just got through talking about, okay? Now, the next thing we're going to go to is this, very familiar stuff. First of all, let's figure out what the sine of theta is, all right? If you don't know this by now, I don't know where you've been. Tell me what the sine of theta is in my triangle. B over R, right? Okay, let's write it down. Okay, so let's put that as B over R, okay, like that, and then let's solve that equation for B. Okay, so the way we do that, of course, you can do this in your head. You multiply both sides by R, so you get this result, B is equal to R sine theta, so I want you to write that down in that blank, okay, like that, okay? All right, next thing I'm going to do is cosine of theta. Tell me what cosine of theta is in this diagram. That over that, right? Okay, it's like side adjacent over side up, or over hypotenuse, or x over r if you prefer to look at it that way. So let's write down what that is. That's going to be a over r, and then we're going to do the same thing. We're going to multiply both sides by r when we do that. So we're going to end up with the result, a equals r cosine theta. Okay, that's an important part of this result. So let's write down in this blank, a is equal to r cosine theta. Okay, everybody with me so far? Okay, that's just basically that same old triangle diagram, Pythagorean Theorem, definition of sine and cosine is what that is. Okay, now here's what we're going to do to put this all together. Okay, first of all, when we do a plus bi, okay, I'm going to write down a plus bi, and what we're going to do is a real simple substitution. A, we're going to replace that a with r cosine theta. So I'm going to do this like this. Just write that as a plus cosine theta. Okay, that is the x component of the complex number. Okay, then what I'm going to do for b, what did we find b to be? That was what? R sine theta. So we're going to write down on this r sine theta, and we still have that times I there. That is like what we call a trig form of a complex number. But we can do some more with that. Notice on this, do you have a common factor? You have an r, right? So take that r out and have a parenthesis. That's what I want you to do next. So if we do that, we'll have r times cosine theta, and then I want you to put the I before the sine theta because it looks better, okay? So this is the result of what I was showing you. That thing right there is called the trigonometric form of a complex number, which is kind of weird. Any number that you could think of could be written with sines and cosines, even the number 1 or the number 0 or anything. We can write it with trigonometric expressions in terms of sines and cosines. So this is what you're wanting to make sure you have down. Z is the variable we use for a complex number, and it's r times cosine theta plus I sine theta. So how in the world are you going to remember this? Well, just this seems to work well. I always call this the r cis theta form. R represents the radius. C represents what? The cosine. I represents the imaginary number, and S is the sine. R cis theta. That's a real simple way to remember that. That'll probably stick in your mind pretty good. All right. So the next question is, what in the world are we going to do with that? Well, that's what I'm going to show you is what we deal with this, how we deal with this. Okay, so what we're going to do first of all, before we start doing much with this, is we want to learn, if I give you a number, how to change it into this form, okay? And actually what you want to do on this is kind of go like this. One thing that's generally helpful, and as I'm doing this, I'm just going to write this at the side. You don't need to write this down. But what we're trying to do on all these problems is put the number I give you into this form. So essentially what you have to do is you have to find the radius and the cosine, or just theta. Really, you find theta. Okay, r and theta is what you have to do. Now, r and theta is in polar coordinates, right? So a lot of times we call this the polar form of a trigonometric number. So what we're going to do on this one is write this as -4 plus 0i. Now, when you do these problems, my recommendation is to always draw a picture. Okay, just graph your number on the complex plane. We spent a lot of time last class a little bit learning how to graph complex numbers. So it goes like this. This is your real axis, like we talked about, and then the y-axis kind of becomes your imaginary axis like that. So if you're going to plot this number, tell me how you would plot -4 plus 0i. Just describe how you do that. You go down 4, right? Okay, no, you wouldn't go down 4. Don't listen to me. You would go which way? Left, thank you. Okay, real number goes that way, so we're going to go left 4 on the real number, because that's the real part, then we put a dot. Okay, so that's where your point is. Okay, now remember I said all we have to do is figure out r and theta, then we have it made. Okay, so the angle, what would that angle be from the beginning to there? What is that? 180 degrees, obviously, right? Now you could do -180, but generally I want a positive angle between 0 and 360. So theta is going to be 180 degrees, like that, okay? Now what r is this. You can always find r by doing r squared equals a squared plus b squared if you need to. But keep in mind, there is a circle going around that point right there. The radius is simply the distance between this and this. What is that distance? 4. So the radius is 4. You can do that in your head. You don't have to do r squared equals a squared plus b squared unless you want to, unless you feel like you need to. Okay, but the radius we're going to use is always a positive number in this. We're not going to use negative radius. Okay, so once we have that, then we just plug everything into this formula. So 4 is going to be the radius, 180 degrees is going to be theta, and then we're done. So the answer to this problem is we would say z equals 4 cosine 180 plus I times sine of 180 degrees like that. Believe it or not, they didn't teach you this in middle school, but the number -4 is really 4 times the cosine of 180 plus I sine of 180. That's what the number -4 is, okay? Does that make any sense? Okay, now I'm going to say one more thing with this. We leave this alone, but if we did this, tell me what the cosine of 180 is.
0.
Careful. That way. -1, right? That would be -1. Tell me what the sine of 180 is. 0. So see, really this right here is -1 plus 0, right? -1 times 4 is -4. So you're right. You can always tell you're right on that, but you leave it in that form because you don't want to do cosine and sine, because if you did, you would just go back to the beginning. So that's what that is. The part of the thing that we have discovered as mathematicians is a lot of times it's easier to work with numbers in this form than it is the regular form. That's what you'll find. One thing that I'm going to eventually lead up to is, like, if you had a complex number like that to the 100th power, at this stage, this is all you guys could do is write it out 100 times and FOIL like crazy. Okay, and it'd take you forever and you'd probably make a mistake. With this new number system, we can do that in like 10 seconds. Okay, seriously, it's that easy to do. Okay, so that's what we're after, is we ended up kind of finding a simpler way to work with numbers by going to this method. Okay, let's go to the next one. And again, when you do these problems, I always recommend that you draw a picture of it. If you do that, that'll help you understand what's going on in the problem better. So this is really 0 minus 3i, with a being the real part and b being the imaginary part like that, okay? So let's go through and let's plot this now. Remember, you have the real axis and you have the imaginary axis. All right, how do you plot 0 minus 3i? You go down 3, right? Okay, good, okay? And see, if you plot this out, then a lot of times you can very quickly figure out r and theta. Now, it's your call. If you want to give me theta, you have two choices. You could give me negative 90, which is what I'm going to use, or you could give me 270. I don't care. It doesn't make any difference. You can use a negative angle if you want to, or you could use the 270. Okay, so I'm going to just, for something different, use the negative 90. Okay, now remember, this point has a circle going around it. The radius on this case you can easily do in your head. What's that radius? It's 3. Now we're going to use positive radius, so that's going to be 3. Okay, once you got that figured out, you're in good shape. So again, what you do is you go to this r cis theta form. Just think of it as r cis theta. So what you do is write the radius, 3, that's that part, parenthesis, c is cosine, negative 90, plus the I, and then the s is sine, negative 90, like that. There's your answer to your problem right there. Okay? So you need to learn how to change these things to this form before we can do anything with it. Yes?
Do you want theta to be in degrees or radians?
It doesn't matter, actually. Okay? The standard thing, a lot of times we use degrees on this, but it does not matter. Okay? If I was testing you over this and I said, if I didn't give you the directions, I wouldn't care. Okay? And you can also, on this, you could use a negative angle or a positive. The standard is this is kind of the way we do it most of the time. If the negative 90, if the absolute value of that number is smaller than that, we prefer the negative. You don't have to do that, but once we get into kind of learning how to do this, it will make sense why you want to use a smaller number, even if it's negative. Does that make sense?
Yeah.
Okay, but like for a test or something, I don't care, as long as your angle is correct in degrees or radians, and then you always want to use a positive radius, okay? Okay, let's go to this next one here. Now we're going to have to do a little bit more calculation on this one, not much though. So again, I always recommend sketch what you have. Okay, this time what we have is we have 6 plus 8i. Okay, that's your real axis, that's your imaginary. How do you plot 6 plus 8i? In words, how do you do that? Over 6 and then what? Up 8, okay? So let's kind of do that and just put a dot there, and I'm just going to say, okay, that's 6, that's 8. And that's good enough for what we need. We just need a visual on this, basically, is the idea. Okay, your job is going to be to figure out what theta is. Okay, that's a quadrant 1 angle, clearly. And then you have to figure out what the radius is, like that. Okay, this is the real axis again, and that's the imaginary axis, like that. Okay, so let's go ahead and let's figure out r. Well, what you have on this is you have a triangle. So you have a right triangle, with that being 8, and this side of the triangle being 6, like that. So, of course, that's Pythagorean Theorem again, isn't it? Right? If you've got 6 and 8 as the legs of that right triangle, then all you need to do is r squared. It's really r squared equals a squared plus b squared, where a is 6 and b is 8. Okay? Right, so let's go ahead and do that and see what we get. So that's going to be 6 squared plus 8 squared. So that looks like that is r squared equals 36 plus 64. So that's r squared equals 100. So what's r? 10, right? Okay, because you can do square root of both sides. So you're going to get r is equal to 10. Okay, so we have that. Now we got to focus on theta. All right, now you got to dig into your trig background a little bit. Now, the thing on this one is, if you have a right triangle and you're finding theta, and you already know the opposite over adjacent, what would be the simplest way to find this? Tangent, probably. Now that you know r, you could use any of the trig functions you want to, but it's kind of standard on this to use a tangent, because if you have a complex number, you're always going to have opposite and adjacent. It's always going to work that way. So since that's opposite over adjacent, we're going to set that equal to 8 over 6, and we'll have tangent theta equals 8 over 6. All right, now 8 over 6, that isn't any magic number on your unit circle. So what do you got to do? You got to get your calculator out. You have to. Now, I'm going to keep doing these problems in degrees. So what I'd have to do is I'm going to make sure my calculator is in degree mode. And then what I basically do is just theta is the inverse tangent of 8 over 6. Now, you're going to get decimals on this, so we're just going to round it. So I'm going to go second tangent to get the inverse to come up of 8 over 6. Okay, that'll give me a quadrant 1 reference angle. So that's going to be approximately, we'll just say 53.1 degrees, and that's good enough. Now, all we can do on this is estimate this. Okay, everybody following along okay so far? Okay, R is always the same. You can either do it in your head or you use the Pythagorean Theorem. Theta is the same way. You can either do it in your head based on what you draw, or you do the inverse tangent. That's what always works. So theta is 53.1 degrees. Now we have the r cis theta form. If you remember that, you got it made. So the r is 10, then you have a parenthesis, c is cosine, the angle is 53.1 degrees, okay, plus I, and then you have the sine of 53.1 degrees like that. That's the answer to your problem. That is the trigonometric form of the complex number 6 plus 8i, okay? If you went through and did the cosine of 53.1 and sine of 53.1 on your calculator and multiplied it out, it would just get you back to 6 plus 8i, that's all, okay? So ultimately in the problem, what are you looking for? R and theta. R and theta, and then using that r cis theta form. Okay, does that make sense to everybody? Okay, all right, everybody good? Okay, let's do one more. Then I'm going to maybe just let you do one yourself here. And again, I'm going to draw a basic diagram. It's always helpful to do that. Okay, now this one we're just going to estimate. All I care about is what quadrant I'm in, mainly on something like this. This one you're going to do what? You're going to go to the left on the real axis and up on imaginary, right? Okay, so we're just going to go left and up. You're going to be up there in quadrant 2 somewhere. That's all that matters in the problem, okay? So then you want to go ahead and draw a picture of the radius like that, okay? Now what you need to do on this problem is two things. You need to figure out the angle theta, and I'm talking about that angle theta, not the reference angle. Your calculator, if you have to use it on this, may give you a reference angle, but I want that quadrant 2 angle. We're going to do that in degrees. Okay, so here's basically what we have. You want to make your triangle. This part of the complex number is called A. So that's A is negative 4 root 2. This part of the complex number is B equals 4 root 2 like that. Okay, now we need to figure out, this time I'm going to do this problem totally without the calculator, okay, because I can kind of see how the numbers are working here. All right, how do you find R? You can't do this really in your head, at least I can't, so what are you going to do? Pythagorean Theorem, right? Okay, you're going to do R squared equals A squared plus B squared. You got to crunch it out. You can't tell what that radius is in your head. So we're going to go ahead and work out what we have. So A is this part, negative 4 root 2. We're going to square that. B is this part, the height of the triangle. So that's 4 root 2, and then we're going to square that like that. Okay? Now, this part, this part right here, I see students mess up on this more than anything else. So you want to be able to just do that in your head. I see people foiling this all the time. So if you did this like this, if you wrote it out twice, is that a FOIL problem? No, I gotta see students do it all the time, okay? It's only FOIL if you have plus and minus in between those. If I had 4 minus root 2 and 4 plus root 2, yeah, you'd FOIL, right? What you do is you just multiply it straight across right out. So if you do that, you'd have 16, and then the roots go together to give 16 radical 4, right? Well, the square root of 4 is 2, so that's going to be 32, correct? You want to make sure you don't mess up on that. That's 32. Now, here's how you do it in your head. You want to just do this in your head. Tell me what 4 to the second is. 16. Boom. Tell me what the square root of 2 squared is. 2, because the radical comes off, right? When you square a radical, it comes off. So you want to do that in your head. That's just 16 times 2, so it's 32. Is this any different? No, it's just a negative number squared, so it's the same thing. So what you're going to have is you're going to have r squared is equal to 32 plus 32. So that's r squared equals 64. So what's r? 8. Okay, so we got that. So we'll end up having r is equal to 8. So that's half of the problem done right there. Okay? Now, you got a couple of ways that you could do this. Now, a tangent is generally what's helpful on this problem. So if you look at this triangle right here, there's a couple ways to do this. What I'm going to do is I'm just going to say, since I've kind of like got a y value and an x value, I'm just going to say tangent of theta is equal to this value. That's like a y value, really. That's what b is. So that's like 4 root 2 over this value. It's really adjacent over, opposite over adjacent, sorry, over negative 4 root 2 like that. Okay? What does this thing become? Negative 1, right? Okay, these things divide out. That's the same number. So really that's going to give tangent of theta is equal to negative 1. Okay? Now if you didn't have a calculator, you actually don't need a calculator for this. You would have to think about, okay, on my unit circle, where does that happen? Where does y over x become negative 1? In quadrant 2, because we know we're in quadrant 2. Where does that happen? 135 actually, right? Okay. So we got, if you look this up on the unit circle, at 135, that's the point that's negative root 2 over 2, comma root 2 over 2, right? So that's where that happens. All right? Now I don't want, like if you did this on a calculator, what you got to be careful about on this is if you did this on a calculator, your calculator is going to give you negative 45. And you don't want that. So let me show you that. So if I do inverse tangent of negative 1, it gives negative 45. The reason it does that, let me ask you guys this. What's the range of the inverse tangent? Negative 90 to 90. Okay, so it's giving you a negative angle because of that reason. But negative 45 is not in quadrant 2, right? You've got to give me the quadrant 2 angle. That's why you're going to have to use 135. You have no other choice. Okay, so you got to be careful about that. The angle has to match the quadrant your complex number's in. Okay, does that make sense to everybody? Okay, now the way that I could tell immediately, I think some of you guys could too, I can tell that's going to be a 45-degree angle. How come? Because those things are the same, right? So if you can see that's a 45-degree reference angle in your head, then you can go 180 minus 45 is 135. But you do have to give me the 135, okay? So what you would have then for your answer on this would be z is equal to r, which is 8. Then you would say cosine of 135 plus I sine of 135 like that, and then you're done. Okay, that's the answer to the problem. Okay? All right, does that look okay? All right, it's not too hard. It's applying things you've learned. That's the idea. It's the idea of a complex number in this form is what's different. Okay, let's go ahead and I'll let you guys work on these two just for a minute here and see what we get here. And then we're going to do this backwards, and then we'll kind of get into the next things here. Just plot your complex number first. Then see if you can put it all together. See where we are on the first one. The first one, hopefully you just did it real fast. First of all, how do you plot 5i? You go up 5, right? So you go up there. Okay, what's the angle? What angle did you use? 90 degrees. What radius did you use? 5. Everybody with me there? See, that's one like that that's a piece of cake, nothing to do. So now what you do is the answer you should have got was 5 cosine of 90 plus I times sine of 90 like that. That's the answer. Okay? All right? The next one, what quadrant is this one in if you plot it? Quadrant 4, right? Because you're going over on the real axis and down. It doesn't really matter how accurate you are. It's just, okay, you know you're there. Okay, so we have, this would be our radius. And then if you draw a triangle out of this, which is what I'd do, is just get a triangle. That a value is really this part of the triangle. That's 2 root 3. That negative 2 is really that part of the triangle. You're going down negative 2 like that, okay? So when you do r, well, you have to use the Pythagorean theorem. You have to do r squared equals a squared plus b squared. So you want to make sure you do that. Generally, the radicals kind of take care of themselves. Not always, though. So this would be 2 root 3 squared, and then plus negative 2 squared like that. All right, did you do that? Okay, all right. So tell me what this thing right here is in your head. 4 times 3 or 12, right? Okay, I see mistakes on that all the time. So be careful about that. That's r squared equals 12. That's 4. So you get r squared equals 16. So what did you get hopefully for r? R is 4. That's half of the problem right there. Okay? Now, what you can do on this, when you want to find the angle, you can always use the tangent. That's a standard way to do that. I'll show you another way in just a minute, but let's start by just doing the tangent. Tangent of theta is going to be y over r. Y is negative 2. R is root 3. I like that. Those 2's are going to cancel out, giving you negative 1 over root 3. Okay? So does that look like a familiar unit circle spot to you? Absolutely. It's got a square root of 3 in it, right? Okay? So what we're going to do is, I know I'm in quadrant 4. And if I'm in quadrant 4, you got two chances. It's either going to happen at root 3 over 2 negative 1/2, or it's going to happen at 1/2 negative root 3 over 2. All you got to figure out is which one would you get a 1 over root 3 out of. Okay, you can get to the point where you just do that in your head, because what are you doing? You're doing y over r. What would happen at this point? You'd have 1/2 over root 3 over 2. What would happen to the 2's? They would cross out, right, okay? So what I tell students to do on that is just see which one's right. So yeah, that's negative 1/2 over root 3 over 2 for the tangent, so that's the right one, isn't it? Okay, so what is this reference angle right there in degrees? It's 60 degrees. But you couldn't give me 60 because that's not in the right quadrant. What would you give me? Did I just say 60? I meant to say 30. Okay, so what would you give me? Negative 30, right? Okay, so that is a negative 30 degree angle. However, if anybody got 330, I'll take that too. It's your call. What you generally do on this is you use the negative one because it has a smaller absolute value. That's why you'll see me doing that, okay? So I'm going to use that for that reason, okay? Now, I want to show you, before I put this final answer together, I want to show you one other thing on this that you can use. And you can go this route if you want to. See, this now, that radius was 4. We found that to be 4. Now, here's what you can do. You can go through on this triangle and divide by every single number by 2. And let me show you what will happen. Okay, this would end up giving you a triangle that has, that right there is going to be 2. This right here is going to be negative 1. This thing right here is going to be root 3. Does that look familiar to you? God, I hope so. That is what? The 30, 60, 90 right triangle. You can do it that way too if you want to. Okay, so that tells you you have a 30 degree reference angle, but since you're in quadrant 4, use negative 30. So the final answer would be 4 cosine negative 30 plus I sine negative 30 degrees like that. That's your answer, problem done. Okay, so see, everything you're doing here is applying trigonometry you've done for a long time now. Okay, that's what makes this stuff easier for students at the end of the semester. Okay, any questions about anything? Okay, all right, now you'll see this kind of stuff on your final exam. You don't really need to worry about doing homework on this over the weekend. You need to get ready for your test. But I am going to put this up here so you can start it if you have a little time. Okay, this right here is actually very simple. This would just be unit circle stuff right here. What you're doing is I'm giving you a trig form. I'm giving you the r cis theta form. If you're going to turn it back into a plus bi form, what do you think you do? What do you think? Just work it out. Figure out what the cosine 30 is. Figure out what the sine of 30 is. And multiply it out, and it'll take you back into that form. Okay, so by now you might be getting to the point where you can do some of this in your head a little bit better. So if you're at 30 degrees on the unit circle, you're at the point square root of 3 over 2, 1/2. Okay, when you get into higher math, if you're in calculus, calculus teacher's not going to say, okay, we're going to do a unit circle. You're going to be expected to know it, and you need to be able to quickly, like I did, figure it out on the fly. Okay, so what's the cosine of 30 anyway? Square root of 3 over 2. What's the sine of 30? 1/2. Okay, so we got it, right? Cosine's x, sine's y. We know that. Now just do a distributive property and multiply it out. So you're going to have 8 over 1 times square root of 3 over 2 plus 8 over 1 times 1/2 like that. Okay, just cancel things out, reduce fractions. That's 8 root 3 over 2, so that's 4 root 3. And then this is 8 over 2. So that's going to be 4. And then that's got the imaginary part in it. So you would end up with an answer 4 times square root of 3 plus 4i. So now you're back in the a plus bi form. That's it. So what makes that simple for students is really what knowledge do you need? You need unit circle knowledge, right? That's it. And then just some basic algebra doing a distributive property. Okay? All right, next one, 270 degrees. Okay, what is that special point on the unit circle there? 0, -1, right? So what's the cosine of 270? 0, sine of 270, -1, correct? So we're going to have 3 times 0 plus -1i. And you do want to have that 0 in there, by the way. That's a standard thing. I want you to do the a plus bi form, so I want to see a and I want to see b. So if you distribute, 3 times 0 is 0. 3 times -1 is -3i. So the answer to that problem is going to be 0 minus 3i, like that, okay? And you want to, as you're learning this stuff, you want to start making connections. All that's happening on this problem is that radius is 3, okay? So that's why you're getting 0 minus 3i, which means straight down, okay? That should be easy enough. What do you think? Yeah, okay, that's not bad, is it? Okay? All right, let's do a few of these, and then I'm going to take you a little bit through what we're going to start doing with these. Go ahead and just do the next one. Just do it real fast. I even got a unit circle for you to refer to, okay? Multiply it out and see if it gives you a logical answer. And then let's see. I think then what I'm going to do is finish up with the product and of okay, all right, shouldn't be no big deal. Okay, we got an answer yet? 3/2, right, plus 3i radical 3 over 2. Okay, you want to write it like this. That's 3/2. Okay, usually you put the I right before the radical, so the best habit to develop is to write it as 3i radical 3 over 2. All I did is the cosine of pi over 3, which is 1/2. Sine of pi over 3 is root 3 over 2, and multiplied it out. That's it. Okay, so that's unit circle stuff. Should be a piece of cake for you, I hope. All right, any questions? Okay, all right, now the next thing I'm going to look at, this is kind of, it gets a little abstract. I'm not going to do all of the steps on the proof of this, but I'm going to give you just a little bit of an idea how this goes. What we're going to do is we're going to multiply complex numbers when they're in this form, okay? Before I do this, though, I want to remind you, like, okay, like from college algebra, you guys should have done this. I hope you did. Like just multiply out complex numbers. Did you do stuff like that? Okay, doesn't that just look like FOIL? That's what it is, okay? Let me go ahead and just do that problem. You can just pay attention to this for review. You don't need to write it down unless you want to. So 3 times 2 is 6. The outside term would be 12i. The inside term would be 4i. Then the last term is 8i squared, right? That's just standard FOIL. These are like terms, so you would have 6 plus 16i. Now, what did you learn about I squared? Hopefully you remember I squared is -1. If not, you need to review that, okay? So what you would end up getting is this. You'd have 16 plus 16i minus 8. These are now like terms, so you would get -2 plus 16i. That's how you multiply complex numbers if they're in a plus bi form. It's basically FOIL. That's all it is, and I squared is going to pop up probably in the problem. So what we're going to do is we're going to do the multiplication in this form now, and it turns out to be super easy. Part of what I hope that you gain a little bit of understanding of, when you're in this trig form, the computations are actually usually easier. Even though that's not hard, what we're going to end up doing is actually going to be just a tad bit easier, okay? So what I want you guys to write down on this is we're going to take this complex number and write it down. That's going to be R1 times cosine theta 1 plus I sine theta 1. Okay, write that down, and then I want you to write the second one down, so you're multiplying by R2 cosine theta 2 plus I sine theta 2 like this. Now I'm going to kind of talk you through the proof. I'm probably not going to go through it real precisely, but just give you an idea of what's going on in this problem. When you do this problem, first of all, what you're going to do is you're just going to multiply those two things together. Those are just numbers, so you're going to get R1 times R2, all right? Now, that's going to leave you with multiplying these two things out. Now, what I highlighted in blue, does that look like FOIL to you guys? Yeah, okay, that's something plus something, something plus something. That is a FOIL problem. So what I want you to do is let's put a big bracket here, and let's start foiling this, okay? So if we do that, we're going to have cosine theta 1 times cosine of theta 2. That's your first term. Okay, now do your outside term. And you have an I when you do that. So we're going to say I cosine theta 1 sine theta 2 like that. So that's the first and outside terms like that. Okay, go ahead and do your inside terms. So if you do that, you're taking this whole thing by that thing. So that's going to be I sine theta 1 cosine theta 2 like that. So you'll get that. Then go to the last term. Okay, you have an I times I, so that's going to be I squared. And then you have a sine theta 1 times the sine theta 2 like that. Okay, now that's fun. I'm doing that pretty quickly because that's just kind of a standard FOIL thing right there. So what I'm going to do, I'm going to kind of I don't want to spend time writing down steps too much. So, of course, what does that become, that I squared? Okay, go ahead and just do this, okay, because you can do this kind of in your head, is just change this part right here to minus. That whole thing's going to be -1, right? Okay, so let's just erase that and make that a minus like that. That's just being lazy. I don't want to write down the next step and write all that stuff out. Okay, now I'm going to see how observant you guys are, okay? I'm going to basically look at those things right there. I do want you to write this down. Let's bring this down as R1 times R2, and then let's group this together. Let's put together cosine theta 1, cosine theta 2, minus sine theta 1, sine theta 2, like that, all right? Now, we're going to put these together. Now, we're going to put those together. If you put those together, couldn't the I just sort of be factored out of that? You have a common factor. So I'm going to have you do that. We're going to write this now as plus, and then we'll have I, and then a new parenthesis, then we'll have cosine theta 1, sine theta 2, plus sine theta 1, cosine theta 2 like that. Okay, partially the reason I want to take time to prove this is to show you that things that you've learned lead to higher math. We use these things for other things. So I want to now see how observant you guys are. Do you recognize this thing? Has that ever showed up this semester? Yes or no? Yeah, cosine, cosine, sine, sine, difference sign. What is that? That's that sum difference identity, right? Okay. How about this thing? Cosine, or I don't know, cosine, I guess I have it backwards. Sine, cosine, cosine, sine, same sign. Okay, that's another identity you learned. Okay, so actually what happens is you end up with this result. Okay, this will still come down. And then this thing right here that I'm highlighting, what that's going to be is that's going to be the cosine theta 1 plus theta 2. Okay, that's the identity for the cosine sum of angles, right? Because what you get on that again is, we said cosine, cosine, sine, sine, different sine, right? That's what that is. And then the next one goes like this. You'll have plus I, and then this one actually is the sine of theta 1 plus theta 2, like that. So what this says, that's the result right there. What this says, if you have two complex numbers in that trigonometric form, you multiply the radiuses together, and then you do the cosine of the sum of the angles and the sine of the sum of the angles. So you just add the angles and multiply the radiuses, and you got it. You don't have to do any foiling or anything. It's actually simpler. Okay, so a lot of times when you're in this form of numbers, things just get simplified. Okay, did you guys follow that proof fairly well? Okay, all right. So let's do a little bit of calculation with this. And these things go pretty quickly, and then we'll wrap this up, and then we'll start talking about our test. So really what I'm going to do on this one, see, is we have two complex numbers that we're multiplying out. Now we're going to just use the formula I just showed you. So what we do is we do this. We do 5 times 2 is 10. We do that. Okay, then we do the cosines, and we add the angles together. So that's going to be 60 plus 90, like that. Okay, then we say plus I, then we do the sine, and you're going to do the same thing. You're going to do 60 degrees plus 90 degrees, like that. Okay? And then what we're going to have is 10 cosine of 150 plus I sine 150. And really the problem's done. That's it. Problem done. That's all you got to do. Now I'm not going to do this last part because students don't generally have trouble with this. If I wanted you to write this back in A plus BI form, what would you do to take this back to A plus BI form? You would just work that out on the unit circle. You'd work that on the unit circle and multiply it out. You guys wouldn't have any trouble doing that, right? I know that, okay? So we just stop there. It's done, okay? Isn't that easy? Okay, so complex numbers, when you're doing multiplication, it's a little less work than FOIL. Okay, let's do this next one together, and then we'll do the this last thing on here with the quotient. And I'm not going to prove the quotient, but the proof's pretty similar. Okay, so this one we just do 4 times 6 is 24. Okay, then we do the cosine of 135 plus 25. You're just adding those angles together. Okay, like that. Then we would have plus I sine 135 plus 225, like that. Okay, nothing to it. This one's probably easy enough that we can go ahead and just finish it off. So that's going to end up being cosine of, that's 360, I think, if I'm doing the math right in my head. And this is I sine 360, like that. So if I want the answer in trig form, you're already done. Okay, problem done, just like that, nothing to it. If I want you to go to A plus BI form, then what you would do is this. Okay, well the cosine of 60 is actually 1. The sine of 360 is actually 0. Okay, so what you'd end up having is 24 times 1 plus 0i, so that would be 24 plus 0i. Isn't that easy? I just think that's amazing. I don't know what you guys think. Okay, we find this new system of numbers, and it just leads us in all kinds of crazy directions on this kind of thing. And it turns out it's super, super easy. Eventually, what we'll talk about a little bit next week is, well, what if we were doing this? And seriously, you'll be able to do that like very, very quickly. Okay, and you're going to find that if you're going to study higher math, like we did polar coordinates, those things often simplify graphing a little bit. Okay, that's kind of the idea. Okay, now let's go ahead and do this one. This one does have a mistake on this. I see this. I keep forgetting to fix this. But what we're doing now is taking two complex numbers and we're dividing those. So let's go ahead and do that, wrap this up. The only thing you guys need to do is you need to change this. That says R1, R2. It should say R1 over R2. Everything else is right. So I'm not going to prove that, but what this is saying is if you divide two complex numbers, then all you got to do is divide the radius and then you do the cosine of the difference of the angles and the sine of the difference. And to me, that's very elegant. To a mathematician, that's just, wow, that's so beautiful and elegant. I don't know about you guys, but I think it's beautiful, extraordinarily beautiful. Okay, now what's going to happen with this is, let me remind you of this thing first of all, and tell me if you did something like this in college algebra. Did you ever learn how to divide two complex numbers like that? Yes or no? Does anybody know how you do it? Well, let me remind you real quick, okay? You multiply by the complex conjugate like this, okay? You multiply it out, you do the foiling, you do all the details, and then simplify. I'm not going to do that, but you probably learned that. You've learned about conjugates. We've done it this semester. That's how you actually divide complex numbers, is to work that out. So what we do is actually less work than that now, okay? So let's go to this last page here and just do a couple of problems, and that's all I really want to do. I'm not going to do the conjugates today because I want to have a little bit of time to review for the test here. So let's just wrap up with a couple of these things and we'll review. Let's see where I'm at here. Here we are. Okay, so let me just show you how you do this. And I'm not going to change it to a plus bi form. Okay, so what we would do with this one is we would just do the radius are these things. That's a radius. 8's a radius. So we just say 8 over 3. That's it. Okay, then on the cosines, what you do is you just say cosine of pi over 2 minus pi over 6, like that. Then you say plus I, and you do the same thing with the sine. You do the sine of pi over 2 minus pi over 6. There's no rationalizing denominators or any of that stuff. It's simply doing that. It's very simple. Okay, now what I'm going to do on this is just get a common denominator. I'm just going to do this at the side. So if I have pi over 2 minus pi over 6, you would have to get a common denominator by multiplying by 3. So what you would end up having is 3 pi over 6 minus 1 pi over 6. So what is that? That looks like 2 pi over 6. So that's pi over 3. Okay, and that's just kind of basic arithmetic. Common denominators, working that out. Okay, now I'm going to write the answer. So we have 8/3 times cosine of pi over 3. And you'll always end up with the same angle. So once you have that, you just write the sine of pi over 3 like that, then the problem's done. Okay, that's it. Okay, so on the multiplication, you added the angles. On the division, you subtract the angles like that. Very quick, straightforward. We have a lot of this kind of stuff on the final exam. If you know the formula and how it works, it's a piece of cake. Okay, let's do this next one. This one's going to be 5 over 4. Okay, then you're going to do cosine of what? 200 minus 50, right? Then you say plus I sine 200 minus 50 like that. Okay, so the final answer is going to be 5/4. You can even do this one in your head. Cosine of 150 plus I sine 150 like that. Problem done. Okay. So that stuff's pretty easy. So once you kind of know how to work with the formulas, very easy to do. Okay? All right. So I'm going to go ahead and wrap up with that, and then I'll